Hello everyone, welcome back. So this is a weekly contest problem for 86. This is the first question that we are going to solve in this video. We have problem number 3818. It's a minimum prefix removal to make the array strictly increasing. Very first, the question saying that you are given an integer that is called nums, right? As you can see, we have given nums like this. So you need to remove exactly one prefix, possibly empty, from the nums, and we have to return an integer which is denoting the minimum length of the remove prefix, such that the remaining array is strictly increasing. What is strictly increasing? Strictly increasing means it should be in the increasing order. Let's suppose if we'll talk about this part, 3 4 5, this is called a strictly increasing. 3 1 2 3 4 5, right? We can say strictly increasing. Okay, so what the question is saying that we have to remove the prefix and we'll make the remaining part as a strictly increasing. Let's suppose if from this array, if we'll remove 1 minus 1 2 and 3, this part if we'll remove, right, what will happen? This prefix, we call this prefix, and the remaining part become what? 3 4 5, and 3 4 5, which is a strictly increasing. Okay, so this is what we have to do. So very first, what we have given, so understand the given problem first. We are given an integer that is called nums, and we are allowed to remove some elements from the beginning, which is called a prefix. So after removing that prefix, the remaining array must be strictly increasing, correct? It means, what is the meaning of strictly means? Strictly means nums at I is less than nums at I plus 1 for all those I, correct? Means the current element should be less than the next element. Okay, what is our task? Our task, we have to find the minimum number of elements to remove from the front, so that what remains is strictly increasing, right? So if you come back here, if you see the size of the prefix is how many letter we have? 1 2 3 and 4, and that is why you are getting the answer is 4. Okay, so this is what we have given in the question. We have to return, we have to find the minimum number of elements that we are going to remove from the front, so that the remaining is strictly increasing. Okay, now understand with a simple example. So let's call, we have 5 3 4 6 7. This is a array we have, and we want to test the prefix to remove, right? So let's suppose we want to remove the prefix. The very first prefix array is nothing but is empty. So the remaining array, we are not removing anything. It means if we are not removing anything from the given array, so it is not a strictly array, because 5 is greater than 3, and that is not getting satisfied. Okay, so let's suppose if we'll remove 5, so remove prefix value will keep as a 5 element, so remaining become what? 3 4 6 7. Now we will check the condition. Current element is greater than next element? No. Current element greater than next. So if you keep checking all, yes, it is strictly increasing, and there is no element such that the current element is greater than the next element, and so it is strictly increasing. So only 5 we have here. It means the minimum removable, how many required, is 1. So this is what we have to do, guys. Okay, I hope you're understanding. So what is the longest strictly increasing which is yeah, longest strictly increasing suffix we have to already present, right? What is the longest strictly increasing suffix already present? It means instead of thinking what to remove, right, from the front, what we can say that think like the longest strictly increasing suffix already present in the given array, right? If I want to start from very first beginning here, or you can take the very first one example, right? So let's suppose if we say, rather than starting from the front to remove, right, can we do from here that if I'll start from 5 4 3, if we'll go from this side, right, means from the right side, and we'll keep checking till strictly increasing follows. So let's suppose 5 4 3, yes, perfect. After that it should be 2, but we are getting 3. It means this part is strictly increasing. Okay, so this is what we are saying, that if we can think like that, rather than removing from the front, right? Can we find what is the longest strictly increasing suffix present, right? The question little it is different, right? Just think opposite, because we can only remove from the front, right? The suffix we keep must already be valid, right? So let's think like this. So let's break down this problem. Very first we have the index 5 3 4 6 7, and these are the indexes. Means for the 5 we have 0, 3 we have 1, like that we have. Okay, so very first if we scan from the right side, right? So in the very first step I'll say start from the right side and we'll keep checking the value. So if we'll start from the 7 and 6, right? Is it fine, right? So very first is we are checking from here, right? Say from the 7 7 6, yes, it is perfect. 4 then we'll check 4 and 6, yes, perfect. 3 and 4, it is perfect. When we reach to here 5 and 3, so 5 3 we have to stop, because 5 is greater than 3. It means the longest increasing suffix is 3 4 6 7, right? Means from here to here, right? What we need to remove? Only the 5. Prefix remove is 5. It means if we'll keep a pointer at this point at the right, we'll keep with the its next value, okay? And we'll collect all the suffix, which is a longest increasing suffix, we can say, and we'll keep all together. So the remaining element will go to the prefix. So the core intuition is this is a trick. So remove the element. The element does not change the order, so that the kept part must already be valid, and the best kept part is the longest strictly increasing suffix. So we have to remove everything before it, okay? And the final algorithm will go from that. We will start a pointer r from the end, and will move left while r minus 1 is less than nums at r, right? So otherwise we'll stop the condition when it breaks and will return r. Let me show you. Very first that we have given is nums we have given, so we'll take n and we'll say this is the size of the array. So r will start from n minus 1, okay? So r will, the nums at r should be greater than nums at r minus 1, okay? If this condition satisfy, means this is the longest strictly increasing suffix, and then we'll keep doing r minus minus, mean we'll keep checking the value, right? Means let's suppose this is 5 4 3, right? So we'll, r is at here 5, okay? So 5 will check with the value 4, means r minus 1. So it is saying that 4 is less than 5, so this condition will get satisfied. It means now r will reduce from 5 to 4 here, right? Like that. So we'll do r minus minus, and this condition will keep going until this condition is get satisfied. We'll return r. So when we reach to the at this 3, so next 3 we will not go, so we'll return the r value, that this is the index we have to return the r, and this answer gets satisfied, your answer will get accepted. So as you see, we are, let's suppose all the elements is strictly increasing in the base cases, so it will go for all the we can say n equal to r will happen, and that is why it will come time complexity O of n. In case of the space complexity, we are not taking extra spaces, so it is a constant. So that's all I have in this video, guys. Thank you for watching this video, and please let me know in the comment section if you want anything else other than the solution. If you are struggling with the structure way of learning, you can join our online classes, so that you have to ping me, and let's go from here. Thank you. Bye bye. I'll see you in the next one.